Hello, welcome everybody to another MeshBaker tutorial. This tutorial is on customizing skinned mesh characters. So I've got this character. I can switch his outfit at runtime to be any of these different outfits. So I've got a bare torso. One of his arms is missing. He's wearing a hoodie. And the visible skin meshes is one the whole time. So this is only one draw call for this character. So in this tutorial, I'm going to show you how to set something like this up, how to overcome some of the problems you'll probably encounter, and a decent workflow for doing this, as well as show you a tool I've written that's included with MeshBaker to help with this process. So let's switch over to Blender and show you what you need to do in the modeler. Hello, here I am in Blender to look at the modeling and what we need to do in order to make these customizable character parts. So here I've got this character. It's been split up into a whole bunch of separate skin meshes. So there's one for each hand, one for the head, one for the pants. The shirt is split into 3 meshes. The arm has been split into 3 meshes, and the torso has been, or the bare torso has been split into a bunch of meshes as well. These meshes have all been attached to the same skeleton. That's an important thing. Don't have multiple skeletons, or don't duplicate the skeleton and have each outfit on a different skeleton. Make sure you're putting all the parts on the same skeleton. Another detail is when you're modeling these parts, make sure that they've been modeled with basically the identity transform. So location 000, rotation 000, scale 111. So each separate part has that, and all the parts align when they're set up that way, and that guarantees when we bake them together in Unity, they will bake together properly. So the other thing is they do need to align, and that means that each part will have a ring of vertexes. Like if I tab in here, this red line here lines up with this same red line in this vertex, or this mesh. So the 2 meshes, the vertexes have to have the same positions. Now, for the meshes to be seamless in Unity, the vertexes in this ring have to have the same vertex position, the same bone weight, the same normal, and the same tangent. So one way to achieve, the first way I tried to achieve that was to duplicate the vertexes in the main mesh, export them as their own object, import them into each of the body parts. Then I would delete the existing vertexes in that part, wire in the new ring, create the faces, remap their UVs and stuff. And that did guarantee they had the same vertex position and bone weight. There was a problem with the normals, which I'll get to in a minute. But the other problem I ran into is that's a lot of work, and it's very tedious. It's easy to make mistakes. And if you decide to change something in your main mesh, and say you've got 10 different arms that can attach to this torso, and I edit some bone weight in the torso, I then have to make 10 copies of that bone weight, go into these 10 different meshes, delete the vertex that's there, wire it in, recreate the faces, recreate the edges, remap the UVs. If I've done baked lighting or something, I have to redo that as well. It's a lot of work. So what I decided while I was doing that process is said, gee, this is something that should be done by a script. I should be able to pick one of the meshes, somehow mark these vertices, and say copy all the attributes on these vertexes to the other meshes. And so I have written that script. It's in Unity, so it doesn't matter which modeler you're using, you'll be able to use it. But you have to set up the meshes properly, which I'll go over in a minute. Now let me talk a bit about the problem with the normals that I mentioned. So in Blender, I don't know how this works in Max or the other modelers, but in Blender, normals you don't have direct control over. Unity or Blender calculates it automatically based on the geometry that is using a vertex. So this vertex has these other vertices as neighbors and these faces as neighbors. So it calculates its normal based on that. The problem is these other faces in the next neighboring shoulder piece are not part of this mesh, so they're ignored. And that means if we look at the normal in this other piece, it's using different faces and edges to calculate its direction. So it's going to be pointing in a slightly different direction. So this one is fairly vertical. And this one is a little more horizontal, and that's going to result in a hard edge going across our shoulder that's not going to look right. So the script I wrote will copy the normals to the vertex, or to all the shared vertexes as well. So that fixes that problem. So let me show you how to use this script. The setup we need to do in the modeler is we need one additional mesh. So I've got all these meshes, and then I've got this other one called the seam mesh. Doesn't actually matter what it's called, but I like to call it the seam mesh so I know what it is. So I put it on its own layer. So this is it. Don't worry about how it looks. Why it looks that way will become apparent in a minute. The important part of this mesh is that it contain all the geometry, and that the geometry at the seams, let me select that. Where's the vertex groups? Go down. How come I don't have seams in here? Vertex groups. That's odd. Am I in the seam mesh? Tab. Oh, there we are. Okay, so I've got the seams. Okay, so the geometry at these seams have been merged, so the vertexes are not duplicated anymore. If you look at the normals, there should be one normal coming out now of the seam. That's good, so that'll make a nice smooth transition across that normal. And then we need a way to mark which of these vertexes are seams and which of these vertexes should be ignored by the tool when it's copying properties. The way we do that is through the UVs. So it's a bit of a hack, but it's a hack that actually works really well. So if you look at the UV map down here, it's the strangest looking UV map you've probably ever seen. The rule is if a UV is below the 0.5 point, meaning it's down in the lower left corner, then that UV will be ignored by the tool. A UV that's in the upper right corner will be treated as a seam. So the easy way to do this is you select all the geometry, you create the UV map, you select all the geometry, you scale it down, you jam it right down into this corner, and then what I did when I did all my modeling is I created this seams group, and in each of these meshes, so when I merge them together, that seams group exists, and then I click select, and it automatically selects all the seam vertexes. And then there's this button in Blender right here. It says keep UV and edit mode mesh sync selection in sync. So anything selected in the 3D view is also selected down here. So then I could easily move those up to this corner, and I'm done. So I've got this mesh that has the bone weights that I want, the vertex positions that I want, the normals and the tangents that I want, and I've marked which vertexes are part of the seams and which are not. So now we're ready to go into Unity and run the tool. Alright, here we are back in Unity. So I've created a new scene, an empty scene. I'm going to start from the beginning on how to run this tool. So the tool is called the bone weight copier. So if we go into game, object, create other, mesh baker, bone weight copier, there it is. And if you select it in the inspector, it's got instructions on basically how to run it. We've actually done the first 6 steps. Those happen in the modeler. Now what we need to do is we need to fill in these fields. So to do that, I have to grab my mesh. So here's my Paint Wars game assets. Let's give it the character controller. looks a little funny, so let's disable some of these meshes that aren't actually part of what we're doing. Press play to make sure there. It's a terrible animation, but let's zoom in, but he is walking in the scene there. Now let's take a close look at some of these seams. There is the problem. So you see this seam here in the shirt between the arm and the thing. There's this crack that's opened up. That's because there's different bone weights on one half and the other. So and yeah, so we're going to run the tool that will fix that. So we go back to the bone weight Copier. First it needs the C mesh. That's easy. We just drag the C mesh into that field. Input game object is the parent that contains all of these objects. Then output prefab, we need a prefab here. So I'm going to go to output. Let me delete all this old stuff because I'm running this from scratch. Delete. Okay, so I'm going to create a new prefab. An easy way to do that is create an empty game object and just drag it into the project folder. We don't want this prefab in the scene. We want the prefab from the project folder. So let's call that fixed character. Go back to bone weight Copier. I drag that in. Output prefab. There we go. And now it wants to. We need a place to save the meshes, so the tool is going to duplicate all the meshes. It's going to fix the vertices in those meshes, and it's going to save those meshes to the project folder. It wants to know where to save them. Let's click this button, set output folder to output prefab folder. So it'll save them in the same place as this prefab. We're ready, so I think we can run the tool now. So it chugs away and it creates all these mesh parts, and it's put the character into there. So let's see how that looks. So I will disable the model that's in our scene currently. I'm going to drag this guy in here. Does he? Yeah, he has the character controller and everything. And whoa, what happened to him? Oh, okay. So I think what happened is if we go back to our bone weight Copier, see how there's this radius field? So that I think was set way too high, because what that radius field does is the way the tool works is it visits all of the vertices in the original geometry, and for those vertices that are marked as seam vertexes, it finds neighboring vertexes and it copies all the properties of those neighboring vertexes into or to be the same as the parent vertex, including the vertex position. And so, the way it decides whether a vertex is close enough is that radius field. And so if that radius field is too high, then you might get this result, this sort of black hole. All the vertices got sucked into the position of one vertex. So let's add a few zeros there, because our geometry is pretty tight. Delete that character. Rerun this tool. Chugs away. Now let's look at our new character. And he's invisible. Why is that? Oh, probably because the original one. That looks much better. And he's got the animator. So let's run him, or make him walk. And take a look at these shoulder. Okay, no more cracks. Not only are there no more cracks, but there's no hard edge there. It's a smooth, curved surface. That's because all these vertexes are sharing the same normal. And if you're wondering what this white stuff is, that's the other meshes here, so I can just hide those, the ones. And so if we just want the orange shirt, that's the way it looks. So that's looking pretty good. So basically we're done now. If I was I'm going to show you how to set up the little setup scene or other script that I wrote that will actually let you switch these meshes around at runtime and bake them together. But if you're solid on how MeshBaker works, then you can probably stop watching at this point. Just one more comment I would make. If it were me, I would not actually use this prefab directly in my game. I would create a duplicate of it. The way I would do that is I'd drag it into the project, give it a different name for game, and drag it into here. The reason is because for your game, you're probably going to add a bunch more scripts to this object. You might add some colliders, you might add a character controller, some sound making things, particle effects, a whole bunch of stuff might get added to this, and if you rerun my tool, those might get clubbered. So by making this its separate prefab, it's sort of one step removed, and then if I rerun my tool, all my tools should have to change are these meshes, and those should get updated in your prefab, and it won't mess anything up. So that's just a tip. Okay, so now I'm going to show you guys how to bake this stuff together so you get one draw call instead of 11 draw calls, and how to set up my little script so you can do this at runtime. So I'm going to open a new scene and set this up. File, new scene. Let's save this. So let's delete the other characters out. So this scene would probably be a setup scene, and its only purpose would be to set up characters. So I'd save it in that crafty folder, call it setup. And its only purpose is just to do that setup that we just did. But a game scene, we wouldn't want all that stuff in the game scene. We just want the fixed character. So first off, let's bake all this stuff together. So game object, create a mesh baker, mesh and material baker. Let's make the character visible so we can see what we're doing. So here, objects to be combined. Well, I could drag them all in manually, or I can use the open tools. So I just want to make sure I've selected the root of that, and then add selected meshes to target. It should have added them all. Material baker, yeah, it added them all. Anything it shouldn't be there? No, that looks all good. Create assets for combined material. So we'll call this combined mat. And I like to almost always use this resize power of 2 and bake materials into combined materials. So it's going to create an atlas for everything. And then we go to set up the mesh baker. Normally I would use same as texture baker, but this time I don't want it because I don't want all those. I just want to pick some set. So let's pick the bare torso items. So I think there's 6 or 7. Where's my mesh baker? So let's go. I think it's 7 pieces that I need. So bare arm left, bare arm right, bare torso, left hand, right hand, head, and pants. So that's all good. Couple other important details. We don't want to bake into a mesh renderer. We want to bake into a skinned mesh because these are all skinned mesh parts. And this clear buffers after bake. So this is a situation where I'm going to initially bake in the editor, but then at runtime I'm going to want to be able to add and delete meshes from what I baked. So to do that, it's important that the mesh baker not forget what's in its buffers. So let's disable that, and then we can click bake, and let's disable all of the meshes so that they are hidden, and we should just see the baked skin mesh. And I've got a bit of a problem with one of my materials. As you can see, the skin wasn't assigned properly. It looks like it's not animating, so oh, that is because, where is my animator? Okay, so the culling settings on the animator, all of these skin meshes that are children of it have been disabled, so it thinks that nothing is visible, so it's culled its animation. So we could set this to always animate. Alternatively, we could drag the new skin mesh to be a child of this, and that should fix the problem as well. So he should walk now. There we go. It's a terrible animation, but it serves the purpose. And as you can see, we've got visible skin meshes 1, and there's still, the seams are still working, and it's all closed up. So now, how do I set up the script to or bake different parts in at runtime? So to do that, we get the script. Well, first off, create a game object to hold the script. So we'll call this scene controller. And then if I go to character customization, swap shirts, there's the scene. Basically, the way the script works, it needs a mesh baker to work with. So let's give it the mesh baker. And then we set up the various outfits. So these are different arrays. So clothing and bare torso, that's going to be the 7 body parts that are currently there. And then the torso damage, this is with the damaged arm, it's missing some body parts, so it's going to have only 6. And then there's the hoodie outfit. So this script, it's very simple. Let me show it to you. It's not really designed to be usable directly in a game. It's just a starting point. So it's an example, very simple, showing how it works. It's only about 50 lines, and about half of those lines are the buttons that let you do the switch. Really, it's just this outfit that changes things. So so you can use this as a starting point, and I'm just gonna edit the video here while I edit all these fields, and then I'll show you the result. I've added all of the outfits. So there's the bare arm outfit, the bare arm with a damaged arm outfit, and the hoodie outfit. So if we push play, the script should do its thing. So it's running now. Let's zoom in on the character so we can see what's going on. And if I click the red hoodie button, it swaps out it removes those other meshes, adds the hoodie, rebake, so we're still at 1 draw call. I can go back to bare torso, swaps those parts out, and we can go to damaged arm, and we lose the forearm and have the bone sticking out. Yeah, so that's it. So Meshbaker is available in the Unity Assets Store. There's also a free version. And yeah, if you have any questions, post a comment. There's also, check out my YouTube channel. It's got a whole bunch of other Meshbaker tutorial videos on it. And email me or post a comment if you have any questions.